Hello children, welcome back to physics class. In today's class, let us discuss in detail regarding the properties of magnets. In general, there are four types of properties we will be discussing. First one, attractive property. Second, directive property. Third, law of magnetic poles. And finally, pair properties. So, let us discuss them in detail. Properties of bar magnets. Okay. So, first one, attractive property. Second, directive property. Third, law of magnetic poles. And one more is pair property. Children, if you were given a bar magnet, we know that it attracts magnetic substances like iron, nickel, cobalt, so on. So, a magnet has a tendency to attract small pieces of iron, and this property of attraction is called as your attracting property. Okay. The points near the ends of a bar magnet, if you consider, whenever this bar magnet is kept inside a heap of iron pieces or iron filings, large number of iron pieces will get attracted at the ends of this bar magnet. Very few gets attracted at the middle, but large number get attracted at the ends of that magnet. These ends are called as your poles of the bar magnet. One is named as north pole, the other is named as your south pole. Okay. So, as I said that every magnet has a tendency to attract iron pieces, and large number of iron pieces are concentrated at the ends of the each bar magnet called as poles of the bar magnet. Okay. So, these substances are called as your magnetic substances. Every bar magnet can attract every other magnet. Every magnet can attract every other magnet. Suppose if you bring up one more bar magnet near the first bar magnet, suppose a north pole is brought near the south pole of the other bar magnet. One north pole, another south pole, if two poles are brought nearer to, or different poles are brought nearer to each other, they start attracting. Similarly, suppose if a south pole is brought nearer the south pole of an other bar magnet, it repels it. Earlier it was attracting, latter case it is repulsing. Okay. So, one thing earlier I said that whenever a magnetic materials like iron, cobalt, nickel are brought near the ends of the bar magnet, it has a tendency to attract all these pieces. Whereas, whenever two opposite poles are brought nearer to each other, they too have the tendency to attract each other. But whenever an opposite pole, like same poles are brought nearer to each other, south pole and south pole brought nearer to each other, they start moving away from each other, called as repulsion. So, we can clearly say that The repulsion is the shear test of magnetism. Why? Because normal also, like magnetic materials like iron also getting attracted to a magnet, whereas opposite pole also getting attracted to a magnet, but only same type of poles will get repelled each other. So, with this we can conclude that repulsion is the shear test for magnetization. Iron is a magnetic substance, but poles will be existing only in magnet. So, in order to identify whether a given material is a magnet or a magnetic substances, we can conclude it like that, that repulsion. Whenever two magnetic substances repel each other, we can clearly conclude that both substances are magnets itself, magnetic substances. I think point is clear. Iron gets attracted, opposite pole get attracted, but only same pole gets repulsion. So, repulsion is the shear test for magnetization. Let us now discuss in detail regarding the directive property. So, what is directive property? Earlier I have discussed it that whenever a freely suspended bar magnet is held, like say suppose this is a bar magnet and it is tied by a string and it is suspended freely. What happens whenever it is hanging by a string of thread, it starts oscillating, moving to and fro, something like this. It starts oscillating, and after a while it comes to some rest position. Whenever it comes to rest position, it shows only towards two position. One is the north direction, the other is south direction. So, a freely suspended bar magnet after coming to rest position shows only two particular direction. One is north direction, the other is south direction. That means it indicates the direction. Hence, this property of the bar magnet is called as a directive property. With the help of this, we can go with the navigation, which is helpful for navigation purposes in ships and flights and many more, and which is also used in compass as compass needle. So, because this shows the north-south direction. So, moving to the law of magnetic poles. So, what are magnetic poles, children? As we have already said that every bar magnet has two poles. One is north pole, the other is south pole. Okay. So, whenever we need that two poles are brought nearer to each other, north pole and north pole attracts each other, whereas south pole of the bar magnet and the north pole of a bar magnet attracts each other. Same poles will go away from each other, opposite poles will come together. That means same poles means we can say it as like poles. Same poles means like poles. That means south and south, they are like poles. So, whenever two same poles, like poles are brought nearer to each other, they start repelling. And whenever a north pole is brought nearer to the south, it starts attracting. They are opposite poles, they are called as unlike poles. So, unlike pole starts attracting each other, whereas like pole starts repelling each other. With this we can conclude that like poles repel each other, unlike poles attract each other. So, law of magnetic poles. This is the law of magnetic poles. What is that law? Like poles repel each other, whereas unlike poles attract each other. Now, moving to the last property, that is all about your pair property. What does this exactly mean? So, whenever you consider a bar magnet and this bar magnet, as we know that generally consisting of a north pole and a south pole, and when this is broken into two pieces, this divides a small bar magnet So when a big bar magnet was divided into two parts, then one has north pole, the other is south pole. Then these two pieces, here no doubt it is north pole and here it is south pole. As now they are made into two separate bar magnets. Again each bar magnet consists of two poles. So this is also, as it is already having north pole, it has south pole, and here north pole as well as south pole. Like this it is being formed. To make you understand clearly, if you divide these bar magnets again into two more pieces, then how does it look like, children? Piece 1, piece 2, third piece and fourth one. When every individual magnet is further divided into few more pieces, each and every piece will contain two poles. Again north pole and south pole. So with this we can conclude this: whenever a bar magnet is broken into two pieces, each and every individual magnet will contain two poles. One is north pole, the other is south pole. So this property of having different pairs is called as your pair property. I hope you understood all the properties once again. Let us discuss in detail. Attractive property means, what is attractive property? So repulsion is the sure test for magnetism. Why? Because a magnetic substance can attract either iron as well as one more bar magnet. So two types of attractions is possible. But a bar magnet always repulses a magnetic substance only, a magnetic, where north pole and south pole is there. So whenever some material is given, in order to identify whether it is a magnetic material like iron, cobalt, nickel, or direct itself is a natural magnet like lodestone or magnetite. So what we have to do is, we have to bring out one more magnet and you have to keep it, place it nearby each other. Whenever they start repelling, then we can conclude that it is, no doubt it is a magnetite. So repulsion is the sure test for magnetism. Directive property: whenever a bar magnet is freely suspended with the help of a string, it aligns in one particular direction, that is called as north-south direction, showing north-south direction, and this property of bar magnet is called as a directive property. What is the law of magnetic poles, children? Like poles always repel each other, unlike poles always attract each other. And pair property means, if you break up a magnet into few more pieces, each and every pieces will have two poles, that is north pole and south pole. So with this we will conclude the concept of this properties of magnet. So keep practicing, children. Let us meet in the next video. Until then, take care. Thank you.